Hello, Professor Jerry here again, and we have another problem of calculus AB. This is on slope fields. So right here in the problem, we are given a slope field, and we are asked to show which could be a following differential equation for the slope field. So to start off, what we do is we focus on each quadrant. In quadrant 1, we know that x and y are positive. X is negative, and y is positive. Right here, x is negative, y is negative. And right here, x is positive, y is negative. Okay, so since the slope here is positive and positive, you can rule out, right here, since the slope is negative all the way through, and when you're at x is equal to -1, your slope is always 0. So that can indicate that this is still possible. Yeah, this is still possible. This cannot be possible because x is -1, and if you would multiply by any number, it would give you a positive. It would give you an actual number, not a 0. So the slope cannot be horizontal. So A is out of the question. Now, what we look at is, since at -1 we have a horizontal slope, we look at the possibilities. This is possible still, and all these four are still possible. So now you look at the other criteria. If you have x times y, and you look at quadrant 1, you know that both are positive. So x times y, let's say you have 1 right here. 1 times 1 is 1, plus y is 2. So this is still possible. Now you look at it from a different quadrant. We'll start off with B. Looking at B in each quadrant. B right here, you have x plus y, x times y, and that'll give you a positive number, minus y. Possibly, it'll be positive, but it has to stay positive as these slopes. And if you have a bigger y, there's a possibility, like right here. If you have 1 times 2, that's 2. And if your y is at 2, 2 minus 2 is 0. So that rules out that B cannot be an answer, as it does not fit in the entire scheme of quadrant 1. Now we look at C. We'll look at quadrant. Let's see which quadrant we can look at. We look at negative quadrant 3. So x and y right here are negative. So negative times negative will give you a positive slope. Plus y is negative. So this is still possible. However, if you look at it in the terms of -1, you would see, actually, if you look at it in the terms of what, -2, -1 right here. If you plug that into this formula, you have -2 times -1 is 1. No, -2 times -1 is +2. With that, you would add -1, which is -1, so it gives you a positive slope. So this is still possible. For C is possible here. Okay, now we look at E. Since E is in question. E, you have x plus 1 cubed. So right here, in this quadrant, when you have a negative number, like let's apply 2, 3, -3 and 1. Right here, since you're only working with x, you plug in -3. -3 plus 1 gives you -2. -2 cubed is actually -8. And these slopes are positive, and the answer is negative for this when you use -3. So that indicates that E cannot be part of the question. So now you're left with C and D. So now we have to figure out which one works. If you use C in quadrants, let's see. Let's test it out in quadrant 4. X is positive. So positive times a negative, that gives you a negative. Plus y, negative. So it's possible. So now let's start plugging in numbers. You have 1, 2, let's work with 2, -2. So if you have 2 times -2, that's -4. And -4 minus 2 will give you -6. So this is possible. And C, that keeps C in still. Now let's work with D. You have 2, -2. So 2 times -2 over here will give you -4. Plus x, that gives you -2. So this is still possible in this quadrant. So you can still have C and D are possible answers still. Okay, here, since we have xy plus x and xy plus y, let's look at it. Let's use the point 2, -1, and plug it into both. Right here for C, 2 times -1 plus 1 will give you plus -1. This gives you -2 plus -3. So this is still a possible answer for this. But when you use D, you get 2 times -1 plus 2, which is equal to -2 plus 2, which gives you 0. So that proves that D will not work at this particular point, because you would have a horizontal tangent, and this does not indicate a horizontal tangent. It indicates negative slope, and the negative slope corresponds with -3, which C, that would provide you with your final answer. And you can plug in many other points, and you'll still get the same results. You plug in 4 and 1, 4 and 2, 4 and -2, you'll get the same answer.
How did you know which quadrant to use to eliminate the other ones?
Well, that's why I labeled each quadrant, and I understand X and Y are positive here, X is negative, Y is positive. You see, with each labeling, you can figure out, and the slopes given, you can figure out. So, for example, in A, X and Y, when you multiply them together, so if you multiply X and Y, you have a -X, -Y, that should give you a positive slope, and it'll work here. However, when you use it at one of these points, you have -1 times +1, that should give you a negative number. And since you have a horizontal slope here, a horizontal tangent, that does not indicate X and Y. So you can cross that automatically. And by using each quadrant, for example, if you use this one in quadrant 4, that's what led to the answer. However, you use it in this one, it can give you multiple answers. So you pick a quadrant to see which equation applies to all 4 quadrants.
Can't you just plug in different points into each equation, just like you did to eliminate C and D?
Not necessarily, not on these two, because they are similar, and since some certain points in some quadrants will give you answers that correspond, however, not all points. So, for example, if you use one of these points all the way at the bottom, it will not apply to both, it only apply to one. However, if you use points pretty close to the origin, it'll result in similar answers, or actual correct answers, so that'll misguide you.
All right.
That's it.